For the first problem, I'm going to look at the second equation first, and I'm going to get x on the same side. I'm going to move the x from the right-hand side over to the left, so I have negative 2x plus y equals negative 5. I recognize that there is a positive y here and a negative y here, so I'm going to add the two equations together. I have 4x minus y equals negative 1, and I have negative 2x plus y equals negative 5. Combine them, I get 2x equals negative 6. Divide both sides by 2. X equals negative 3. So that's part of the answer. Then I'm going to use 4x minus y equals 1, and I'm going to substitute in minus 3 for x. And I get 4 times minus 3 minus y equals, that's a negative 1 up there, sorry, negative 1. Let's make that negative at the very beginning, I believe, right up there. So negative 12 minus y equals negative 1. I can move y over here and move negative 1 over here, and I end up with negative 11 equals y in the second part of my answer. Next, number 2. For the second equation, I recognize I have a positive 2x in my first equation, a negative 2x in my second equation. So if I combine these two equations, I will get rid of my x. I get negative 2y equals negative 6. I now divide each side by negative 2. I get y is 3. Simple enough. Now I take that, I'm going to plug it into this equation. So I'm going to take 3 and I'm going to plug it in for y. I add 3 to both sides, equals negative 2. Divide each side by 2. X equals negative 1 is my second answer. For the third problem, I again will use elimination because I recognize that I have a negative 1/2 x and a positive 1/2 x. And not only will this get rid of x, but it will also get rid of my fractions. So my left-hand equation is y equals 1/2 x plus 2. Underneath that, y equals positive 1/2 x plus 6. Add them together. 2y equals 8. Divide by 2. Y equals 4. Now I want to take that, I'll plug it into the second equation because there's no negatives. It makes it a little bit easier to use. And x now is going to plug in there for that x, the 4. Oops, sorry about that. It's not going to do that. Plugging in for y, isn't it? Okay. So I'm going to plug that in for y. Hold on one second. There we go. Alright, 4 then equals 1/2 x plus 6. Hold on. Alright, taking away 6. Negative 2 equals 1/2 x. Multiply both sides by 2. The 2 and the 1/2 cancels out. And the 2 times negative 2 is negative 4. And there's the second part of my answer. For number 4, I recognize 2y here and a 2y there. In this case, I'm going to use substitution. And I'm going to take x minus 1 and substitute it in for that 2y, which leaves me with 7x minus parentheses around x minus 1 equals 1. Make sure you distribute through this negative sign to both terms inside. So we're going to get 7x minus x plus 1 equals 1. I get 6x on this side. Take away 1 from both sides equals 0. So x is 0. 0 is a perfectly good answer. Now to solve for y, I'm going to go ahead and go to the second equation, x minus 2y equals x minus 1. Substitute in 0 for x, and I get 2y equals negative 1, y equals negative 1 half. For this problem, I think I'm going to use substitution as well, because I see that I have y equals in my second equation, and I'm going to plug it in for the y in the first equation. So I will write that down. Alright, and then I'll distribute through the 2 and see what we get. 3x, the 2 and the 1 half will cancel out. Leave with x minus 8 equals 23. Combine like terms. Move the 8. Divide by 4. And I've solved for x. 31/4. Not a real pretty number, but it works. Now I'm going to take 31/4, I'm going to plug it in. I'm going to plug it into 1/2 x minus 4 equals y. So 1/2 times 31/4 minus 4 equals y. That gets me 31/8 minus 4 equals y. Combine 31/8 and negative 4. Well, let's go ahead and make 4 a fraction with 8 as the denominator, which will become 31/8 minus, multiply by 8/8. You get 32/8 equals y. And then I'll go back this way. Y then equals negative 1/8. So for number 6, I think I'll use elimination. I'm probably going to multiply the top equation by negative 2, or the one on the left, and the right equation by 3. I'll set that up. So I'll distribute through the negative 2. So I get negative 6 minus 4y equals negative 34. And then I'll distribute through the 3. I get 6x. So you see what I'm doing is getting rid of the x variable. And this equals 78. Now, I multiply by negative 2 and multiply by 3, so I've changed the sign of x. So you see that the x's will cancel out. And I get 11y equals 44. Divide by 11. Y equals 4. I will plug that back in over here. 2x plus 5y equals 26. So again, I'm going to plug in y for that right there. And I get 2x plus 20 equals 26. Take away 20 from both sides. 2x equals 6. X equals 3. Here we go. Alright, so I forgot to hit record when I was writing that one down. Hopefully you can follow it. I multiplied the left-hand equation by 2, added them together, y canceled out, solve for x, and then solve for y. For these pair of equations, I'm going to get rid of the fractions right from the start. So I'm going to multiply this equation on the left by 6, because 6 is the least common multiple of 2 and 3. Alright, and that's going to get me 2x plus 3y equals 0. And I'm going to multiply the second equation by 10, because that's the least common multiple of 2 and 5, which are the denominators in that equation. So that's going to end up with 5x plus 2y equals 22. So, looking at these two equations, I think it's going to be much easier to work with. Now, unfortunately, I think I'm going to have to multiply those by another number so that I can then use elimination. So I'm going to go ahead and multiply the first equation by 5. So make sure, so 5 times 2x plus 3y equals 0, and that's going to result in 10x plus 15y equals 0. I'm going to take the second equation, I'm going to multiply it by negative 2. So I'm multiplying 5x plus 2y equals 22. So you see my x values will now disappear. When I add these two equations together, the x's cancel out. I get 11y equals negative 44. You divide by 11. Y equals negative 4. I take negative 4 and I plug it into probably the first equation. The 1/3 x plus 1/2 y equals 0. So I have 1/3 x plus 1/2, and this is where I substitute in negative 4 equals 0. 1/3 x minus 2 equals 0. Move the negative 2 to the other side. So I'm going this way. 1/3 x equals 2. X equals 6 when I multiply both sides by 3. Alright. The next problem asks me to graph an inequality, which means I'm going to first graph the line y equals 5x minus 5. I note that the y-intercept is negative 5, so 1, 2, 3, 4. I'll do this in blue down there. The slope of the equation is 5, which means I will go up 5, 2, 3, 4, 5 over 1. So up 5 over 1. I also note that this is less than. It's not less than or equal to, so this will be a dotted line. Like so. Well, sort of like so. Alright. Now the last piece is I must shade. So I'm going to check a point. I'm going to check the point 0, 0. So is 0 less than 0 minus 5? Is 0 less than negative 5? It is not, which means the point 0, 0, which is here, does not satisfy the equation. So I need to shade the other side, which is this side. The next equation is also an inequality, so I'm also going to be graphing the line first, then shading. So I'm going to get rid of the inequality sign. Now I want to solve for y, and they're all divisible by 2, which makes it nice and simple. So y equals 2x minus 3. So my y-intercept is negative 3, which is here. And the slope is 2, which means I go up 2 over 1, up 2 over 1. This is greater than or equal to, so it's a solid line, which is much easier to draw. There we go. And I check the point 0, 0. So I go back to my original equation. It's just safer to use that. So 0 is greater than 0 minus 6. Is 0 greater than or equal to negative 6? Yes, it is. So we're going to shade above that line. The next equation, I'm going to solve it for y. And I'm going to add y to both sides. So I get 4x is greater than y plus 2. I'm going to take away 2 from both sides. I get 4x is, whoops, not that. 4x minus 2 is greater than y. Then I look at the line itself, so I just plug in an equal sign. The y-intercept is negative 2. My slope is 4, so 1, 2, 3, 4 over 1. It was just greater than, so it is another dashed line. There we go. I then am going to pick a point. 0, 0 looks like it's to the left of that line. So if I plug 0, 0 into this equation, or I could plug it into the original equation too. Let's do that actually. Let's plug it into the original equation. So then I get 0 minus 0 is greater than 2. Is that true? No, it's not. So I shade below the line again. Number 12 is asking me to graph two inequalities, and I'm going to then look for the intersection of the two shaded regions. So let's go ahead and create our graph. So the first equation I'm going to rewrite as an equality, so 2x plus 4. I'm going to label this A, so when I draw the line, you can see which line it is. So the y-intercept is 4. The slope is 2. So I could go up 2 and over 1, which puts me about here. I could go down 2 and over 1, which puts me about here. I can go ahead and draw my line. Looks something like that. And I'm going to label that graph A, and that's the blue graph. Now I'm going to go ahead and graph the second equation. Now I recognize that negative 3x minus 2y, I can make it an equality. I'm going to label this one, I'm going to color it red too. I'm going to label it B. Because 3 and 2 both go into 6, I'm going to graph this one by plugging in 0 for x and then 0 for y. When I plug in 0 for x, I get 0 minus 2y equals 6, or y equals negative 3. So that gets me my y-intercept. So I'm at negative 3 down here. And then I go ahead and plug in 0 for y. And I get x equals negative 2. So it looks like those two graphs are going to intersect right there. I'm going to go ahead and, oh, I missed that one. Well, you know where about it goes. So we're going to stick with that. I then have to shade the two graphs. Let's look at A first. A was y is less than or equal to 2x plus 4. Plug in 0, 0. So I get 0 is less than or equal to 4. Is that true? It is. So I'm shading this side of A. All right, and I forgot to label this graph B. I'm going to go ahead and plug in 0, 0 for the second equation. And so I'm going to go 0 minus 0 is greater than or equal to 6. That is not true. So we're going to have to shade below the line B. And you see, and so the intersection of the two graphs is this region in here with more lines. All right, so number 13. Graph A, y is greater than or equal to 2x minus 5. I can write it as a linear equation. So y equals 2x minus 5. The y-intercept is at negative 5. So whoop, I got to put one more hash mark down here. Down here. My slope is 2, so I go up 2 over 1, up 2 over 1, and it's going to go up fairly steep like so. This is graph A. It's nice to label them so you can come back later and know which side, which line you're talking about. And then go ahead and plug in a 0, 0. So I have 0 is greater than or equal to 0 minus 5. Is 0 greater than 5? Negative 5? Yes, it is. So we're going to be on this side. Then I'm going to go ahead and y is greater than 5. So I just go up to y equals 5. 1, 2, 3, 4, 5. And it's going to be a horizontal line, and it's going to be a dashed line. Just making sure I copy that down right. And it said y is greater than 5, so it's going to be above that. So our final answer is this region up here. I didn't do much red up this way, but it's going to be this region up here. Alright, so here are the two equations for 14. I'm going to solve for y in the first equation here. I'll move it over a little bit. I'm going to take away 6x from both sides, so minus 5y is less than minus 6x plus 15. Then I'm going to divide each side by negative 5. Y, note that I have to flip the inequality sign. This will be 6/5 x minus 3. I can go ahead and graph that. I'll make that one A. The y-intercept is negative 3. The slope is 6/5. So I'm going to go 6 rise. 1, 2, 3, 4, 5, 6. Then run of 5. 1, 2, 3, 4, 5. It is a dotted line. And look like that. While I'm on it, let's label the line first. Then let's go ahead and plug in 0, 0. 0 is greater than 0 minus 3. 0, 0 does work, so I'm going to be shading above that line. Now I go ahead and take a look at the second equation. I have x plus 2y is greater than or equal to 7. Again, solve for y. Divide by 2. Y is greater than or equal to negative 1/2 x plus 3/2. 3/2 is my y-intercept, 1.5, so about there. The slope is negative 1/2, so I go up 1 over 2, so it's going to be going in, and it's one line. See if I can do this. There we go. And that is equation B. And now I try 0, 0 into this equation. 0 is greater than or equal to 0 plus 3/2. It does not work. 0 is not greater than 3/2, so I'm going to have to shade above my blue line, so my final answer will be that quadrant there. So number 15 is a word problem, and we recognize it as one where we will find exact answers. We're not going to be shading. There's no saying at least or more than. We're going to find exact answers. So I'm going to call haircuts X. I'm going to call hair dye Y. Always write that down. So my first equation, 3x plus 2y, it took the person 315 minutes. The second equation was 2 haircuts, so 2x plus 4y equals 450. I recognize that I have a 2y and a 4y. If I just multiply the top equation by 2, I will then have the same number of y's. So I will do that. So 6x plus 4y equals 630. And I just bring that equation over. 2x plus 4y equals 450. Now I'm just going to subtract the second equation from the first one. So when I subtract, I get 4x equals 180. Divide each side by 4. X equals 45. Okay, so remember x also stood for the number of haircuts. And then I'm just going to take 45 and I'm going to plug it into one of the two equations. Just plug it into the second equation to this one here. So I get 2 times 45 plus 4y equals 450. 90 plus 4y equals 450. I'll take away 90 from each side. 4y equals 360. Divide by 4. And I get y equals 90. And again, that is the hair dyes. The second example, it is similar to the first one. Again, we want to label. How about we label a small centerpiece as x, the large centerpiece as y. So I get 3x plus 3y equals, now 3 hours and 15 minutes. I think what I want to do is convert that all to minutes. So 3 hours plus 15 minutes is going to be 195 minutes. The second equation, we have 4 small centerpieces plus 7 large, and I have 6 hours and 20 minutes, which converts to 380 minutes. So now I just have to probably use elimination. Multiply the top equation by 4 and the bottom equation by 3, and I will be getting rid of x. So I distribute through each of those two numbers and we'll see what we get. So that's what I get when I multiply. I'm going to subtract the second equation from the first. I always put parentheses around it so I remember to distribute through my negative. The 12x goes away. Negative 21y and 12y ends up to be negative 9y. Negative 1140 plus 780 equals negative 360. Divide by 9. Or divide by negative 9, my mistake. And you get y equals 40. So that is the large centerpieces. Now I go ahead and plug 40 into one of the two equations. I will use the first equation, so 3x plus 3 times 40 equals 195. 3x plus 120 equals 195. Take away 120 from both sides. 3x equals 75. X is 25 small pieces. And we're done with that one. The next problem also is one where we're going to set get equal signs, not inequalities. So we're going to call horseback riding X. We're going to call parasailing P. So we get 192 equals 3 hours times, or 3 hours. X is the amount it costs to horseback ride, and P is the amount it costs to go parasailing. So there's our one example. And the second one is 2x plus 3p. Alright, so I'm going to go ahead and well, I used x and p versus x and y, but that's okay. So I'm going to go ahead and multiply the first equation by 2, the second equation by 3. I'll be getting rid of the x term. So I'll multiply that through and we'll see what we get. So that's what we get. I'm then going to subtract the second equation from the first. It may be easier actually to do it the other way around. Then you get positive numbers, but I think we're okay. So negative 255 equals, you'll see x, because that negative distributes through, 6x minus 6x goes away, and negative 5p, divide both sides by negative 5, and you get the price of the parasailing to be $51. We then plug 51 in for p. Go ahead and use the first equation. 192 equals 3x plus 2 times 51, and we solve it. So then I'll subtract 102 from both sides. 3x equals 90, or the cost of the horseback riding is $30. In this example, it's a little bit different. You're going to have to use inequalities. And one thing that tips you off is one of the sentences where it says you want to download at least 12 files. When you see phrases like that, you're going to have to use an inequality statement. So let's look at one. We have 60 megabytes of space. So we have 60 megabytes of space. And we're going to, that's the most we can have. So what on the other side of the equation is going to be less than that. We're going to call video file, files that use 3.5 megabytes of space, or video files. Video files we'll call y, the other files we'll call x. So 3.5x plus 8y is one of the equations. The other one, we want to download at least 12 files. So we want to x plus y to be at least equal to 12. So there are two equations, and the other two we don't mention but are assumed is that both x and y must be greater than or equal to 0. It doesn't make any sense if you get negative numbers here. So now I'm just going to go ahead and graph those three equations, or two equations, and then also keep in mind the x and y are both greater than 0. When I'm graphing that first equation, 60 equals 3.5x plus 8y. The easiest way to do this is to plug in 0 for x or y and solve for the other. So I plug in 0 for x and I get, well, that becomes 0. I divide by 8. Alright, so I get y equals 7.5. Then I go ahead and I plug in 0 for y. And I get 60 equals 3.5x. I divide both sides by 3.5. And I get x equals 17. So, I'll graph that one in blue. My x-intercept is 17. My y-intercept is 7.5. So 1, 2, 3, 4, 5, 6, 7. So right about there. And I can go ahead and try to draw a straight line, sort of. So that is that line. The second line I'll graph in red, label that B, x plus y equals 12. Well, the x-intercept is going to be 12. The y-intercept is also going to be 12. It's going to look like that for B. Now for B, if I plug in 0, 0, I get 0 is not greater than 12, so it's going to be above it. So it's going to be out this way. For the line A, if I plug in 0, 0 into 60 is greater than 0. Is that true? Yes, it is. So I shade below the blue line. So I think in the end, I'm going to end up with this little triangle right here, because x and y are also greater than 0. And that's what we end up with. All right, this is another example where you're going to have to use inequalities. Let's call mowing lawns, the number of lawns you mow, X, and the number of hours you're in the clothing store, Y. Let's make sure we get that X. So, what do we get here? How much do you earn? Well, you need to earn at least $350. So, let's make that $350. You need to earn at least that. So, the right side's got to be greater. And $12 times the number of hours you spent mowing lawns plus $10 times the amount of time you spend in the clothing store. It also says you can work no more than 35 hours a week. So X plus Y must be less than or equal to 35. And the last piece, it says you must work at least 10 hours at the clothing store. So Y must be greater than or equal to 10. All right, so we have three equations, and that's no problem. We can go ahead and graph all three. And again, X and Y both have to be above 0, so I'm only going to graph in that first quadrant. Okay, let's go ahead and graph that first line. And I'm going to use the method I talked about before, plugging in 0 for X and 0 for Y. So first I'm going to plug in 0 for X to get the Y-intercept, and you'll see that the Y-intercept is 35. Then I'm going to plug in 0 for Y, divide each side here by 12, and I get that the X-intercept is going to be 29. Alright, so I graphed that one in blue, so from 29 to 35, and I'm going to get that line there. If I plug in 0, 0, label that A. I plug in 0, 0, is 350 less than or equal to 0? No. So it's going to be above this line, so it's going to be up here. I don't put too many marks because there are going to be other lines and I don't want to get it too messy. Next, X plus Y equals 35. Well, I can go through the same process of plugging in 0 for X and 0 for Y, and you'll find that the X and Y intercepts are both at 35. So I go ahead and graph that line there. I plug in 0, 0, and I'm going to shade below the red line there, so down here. So right now the only piece of real estate that's any good is the area between the two curves. The last line, I'll do in black, Y is greater than or equal to 10 is a horizontal line here. And it says Y is greater than 10, so it's going to be above it. So what intersects all three areas is this weird little triangle right here. So that's the only area where you can work so many hours and satisfy all the requirements. All right, this last problem, I'll put the equations here, and then on the next slide I'll have to draw the graph. Let's call hours of basketball X. Let's call homework Y. So the first thing is you can spend at most 6 hours playing basketball and doing homework. So X plus Y must be less than or equal to 6. The second, you want to spend less than 2 hours playing basketball. Basketball was X, so X must be less than or equal to 2. And the last piece, at least 1.5 hours doing homework, so Y must be greater than or equal to 1.5. We'll see if we can fit that in here. So I have a graph here, and we'll call this graph A. Well, we know it's got to go through the Y. X and Y intercept are both 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that line's going to look like this between the two intercepts. And x is greater than 2, so there's x equals 2. And I forgot to shade the first one. The red is going to be shaded below. If you put 0, 0 in, you'll see that. X is greater than 2 is to the right of that line. And y is greater than 1.5. There's y is greater than 1.5. Or there's y equals 1.5. So y equals 1.5. And it's got to be greater, so it's got to be above that. Okay, I made a mistake back here. When I said x is going to be shaded to the right, that's wrong. It says x here is less than 2, so it's going to be this side of that black line. Since it's going to be that side, and below that, and above that, we end up with this area right here. All right, we're done. Good luck, guys. Be safe with the snow.